So today's crash course is on periodic table. So for our agenda, we'll be going through the properties of group 1 elements. Okay, then there'll be a structured question for you to try. Then properties of group 17 elements. Okay, then after that, MCQ and structured question. Then after that, I'll go through both properties of group 18 and transition elements. And then I'll give you MCQs to try. Okay, so this is just the main parts, the main important parts that I'll go through. Your group 1 elements, group 17, group 18, and transition elements. Then at the end, there'll be a Kahoot quiz. So a short quiz to test your knowledge. Okay, then there'll be class details and a feedback form at the end. So I'm doing these crash courses for free, right? So all I ask in return is for all of you to complete the feedback form. Okay? Okay, Zichao, your friend, right? Did he manage to enter the meeting? I think I missed out his name when I was sending out the stuff. You managed to send him the meeting link? Okay, thumbs up. Okay, can. Right, so when he requests, then I'll just let him know. But if not, I have to start first because it's already 8:03. Okay. Okay, so let's start with group 1 elements. So group 1 elements, of course, they are metals. Okay, and then they are known as alkali metals. So later we'll learn why they are called alkali metals. So the special thing about your group 1 elements, right, is they are very reactive. Okay, so when they react with water, when they come into contact with water, there will be this very explosive, very reactive reaction. Okay, this violent reaction. So how do we store the group 1 elements? We store them under oil. Okay, so this oil acts as a barrier to prevent the group 1 metals from coming into contact with water. So that's why your group 1 metals are stored under oil. Okay, because this is because they can react spontaneously with water. Okay, or just moist conditions. And the reaction is very exothermic, very violent. So it releases a lot of energy to the surroundings. Okay, then your elements in group 1 are lithium, sodium, potassium, rubidium, cesium, and francium. Okay, so exactly this order, this is your group 1 metals. Okay, later I'll be referring to this for your trends down the group. So let's look at their reaction. Okay, so they have very violent reactions with water, right? What exactly does it form? It forms, so a group 1 metal reacts with water to form an alkali and hydrogen. Okay, because it forms alkali, that's why they are called alkali metals. So your alkali is actually metal hydroxide. Because what's the definition of an alkali? It's a substance that ionizes in water to produce your hydroxide ions, which is your OH minus. Okay, so your alkali has to be a metal hydroxide so that it can produce hydroxide ions. So let me give you an example. One of the group 1 metals is sodium. Okay, so sodium reacts with water to form the alkali. So your alkali is a metal hydroxide, right? So it will be sodium hydroxide. Okay, your metal is sodium and then hydroxide is OH. So NaOH. And then hydrogen will always be another byproduct. Okay, so group 1 metal plus water give you alkali and hydrogen. Then all you need to do is balance the equation. And that is your equation for reaction with water. Okay, now let's look at the physical properties. Okay. So for your physical properties, you know that these are group 1 metals, right? So they basically will have the same physical properties as other metals. Okay, because these are group 1 metals. They are metals. So they, of course, will have similar physical properties as metals as well. And what are some of those properties? We know that metals are shiny. Okay, they are good conductors of electricity and heat. Okay, because metals, they have the delocalized electrons to conduct electricity and heat. They are ductile and malleable. Okay. And those are the properties of metals. So what are the special properties of group 1 metals? Listen carefully. These are the 3 properties that will differentiate your group 1 metals from your or other metals. Okay. So your group 1 metals, what is special about them is that they are soft enough to be cut by a knife. Okay. So your sodium, lithium, all these metals, they are all very soft. Then the next property is they have low density. Okay. So compared to all the other metals, your group 1 metals, they have relatively low density. And they also have low melting and boiling points compared to the other metals in the periodic table. Okay, so these are the 3 properties that are similar in group 1 metals, but are different in other metals. Okay, one is they are soft to be cut by a knife. The other one is low density. And the final one is relatively low melting and boiling points. Okay, compared to other metals in the periodic table. Because metals, they are known to have high melting and boiling points, right? For group 1 metals, it is slightly lower. Okay, so that is the physical properties. Now let's move on to chemical properties. So again, because they are metals, they will have the same chemical properties as other metals. So what are some of those properties? They can react with non-metals to form ionic compounds, right? We learn in chemical bonding that your metals react with your non-metals to form ionic compounds. Okay, they can also react with acid to form salt and water. That is one of your acid reactions, right? Your acid plus metal give you salt and water. Okay, that is another chemical property of your metals. Okay, so the only thing is different is, since they are group 1 metals, right? One of the similar chemical properties is that they have one valence electron. Okay, so pretty straightforward. They are found in group 1, so they have one valence electron. And because they have one valence electron, they will lose one electron to form your positive ion of +1. Okay, basically the charge is +1 when it becomes an ion. And what is the reaction that we just learned? Group 1 metal plus water to give you alkali and hydrogen. Okay, that is another chemical property. So they can react vigorously with water to form your alkali and hydrogen gas. Okay, so these are the 3 chemical properties that differentiate your group 1 metals from your other metals. Okay, moving on to the trends down the group. So these are your differences. What is something that changes down the group, down your group 1 when the atomic number increases? Okay, so if you look at the periodic table, right, you have lithium, sodium, potassium, rubidium, cesium, and francium. Okay, so you have this order. So now let's go back to the notes. I've written this order exactly like that. So what are the trends down the group? I have a memory shortcut for this. Okay, so it's DARM plus, 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 minus. Okay, so your plus means increase. Your minus means decrease. Okay, so this is the easiest way to remember for your trends down the group. So we start with D. D is density. Okay, density increases down the group. Okay, so down the group, right, lithium will have the lowest density, and francium at the most bottom will have the highest density. That is your first trend down the group. So as it goes down the group, the density of the elements increases. What is A? A is atomic radius. Okay, or atomic size. So what exactly is atomic radius? We know that as you go down the group, right, the number of electron shells increases. How do I know this? Look at lithium. Lithium has three electrons, right? So what will be the configuration? The configuration is 2, 1. Right? So how many electron shells does lithium have? 2. Then let's look at sodium. Okay, sodium is 1 below lithium. Sodium has 11 electrons. So the configuration is 2, 8, 1. Okay, 2, 8, and 1. So how many electron shells does sodium have? It has 3. Okay, then as you go down, lithium will have 2 electron shells, sodium will have 3 electron shells, potassium will have 4 electron shells, and so on and so forth. Okay, so the number of electron shells increases down the group. So as it increases down the group, right, the atomic radius also increases. What is atomic radius? It's basically this distance here. I'm going to highlight it from the middle to the end. Okay. The distance increases, the atomic radius increases. So the atomic size of the whole atom also increases. That is your second trend. Okay. So lithium is basically the smallest in size, and then francium is the biggest in size. That is your atomic radius or atomic size. Okay, now moving on to the next letter, R. R is reactivity. Oops. Okay, there's a plus on top, so reactivity increases down the group, meaning lithium will have the lowest, sorry, not lowest. Lithium is the least reactive. Francium is the most reactive. Okay, down the group, the elements get more and more reactive. That means when you put lithium and water together, the reaction will not be as vigorous as when you put francium and water together. Okay, when you put francium and water together, will be like a whole explosion. But lithium and water will just be a small violent reaction. Okay, so reactivity increases down the group. Okay, last one, letter M. M is melting and boiling point. Okay, your friend is here. Melting and boiling point. Okay, Kriti asks, does this mean down the group from lithium to francium, the size increases? Yes, the size of the atom increases. Okay, the atomic size increase. Okay, so now we're at the last letter M, which is melting and boiling point, and minus, it means decrease. So down the group, the melting and boiling point of the elements will decrease, meaning that lithium will have the highest melting point and boiling point, and francium will have the lowest melting point and boiling point. Okay, the one who just joined Earth Fun, we are over here. We're going through this memory shortcut, and this is the trends down the group. Okay, so the memory shortcut is DARM plus 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 minus. So D is density, density increases down the group. Atomic radius increases down the group. Reactivity increases down the group, and melting and boiling point decreases down the group. Okay, so this is for your group 1 trends. Okay, so now I want you guys to try question 1. Okay, question 1, I'll give you all 6 minutes. If you have done the questions already, you can just take a small break. Okay, so 6 minutes for question 1. I'll go through at 8:22. Okay, so see you guys at 8:22. And then you guys can send your answers in the chat, and I can help you. I can give remarks to your answers. Okay, so there's an in-call messages. You can send your questions or answers there. Yeah, and I can give some feedback. So I'll go through at 8:22. Okay, let's look at the question. So state 3 physical properties which can extinguish group 1 metals from the other metals. Okay, so the first physical property that will differentiate them is it is soft, which can be cut by a knife. Okay, so there was one answer saying soft, malleable, and can be cut by a knife, but there's a difference between soft and malleable. Okay, so malleable means it can bend easily. Okay, when a force is applied to it, it can bend easily, but soft means that it can be cut by a knife. So it's two different things. Okay, and malleable, right? Other metals are malleable as well. So it's not a property that can extinguish group 1 metals from other metals. So that's the first one. Second one is that it has a low density. Okay, then the last one, they have relatively low melting and boiling points. Those are the 3 physical properties. Okay. Moving on to part B. State 4 important trends down the group for your group 1 elements. So your trends down the group, remember the memory shortcut? DARM plus 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 minus. Okay, so D is density. Density increases. Okay, that's the first trend down the group. Second is A, which is atomic radius or atomic size. Both are accepted. So atomic radius increases. The third one, R is reactivity. Okay, so the reactivity of the elements, of your group 1 elements, they increase down the group. M is melting and boiling point. Okay, there's a minus on top. So melting and boiling point decreases down the group. Okay, there's a question. If alkali metals get more dense down the group, why does potassium have a lower density than sodium despite being below sodium? So if it's below sodium, it should have the higher density. First, what is density? Density is mass over volume, right? Hold on, let me erase this. Density is mass over volume. Okay, so let's say now the volume is the same, right? Volume is the same. If there's a higher mass, there's a higher density. And potassium is heavier than sodium because potassium has a mass number of 39, right? Yeah, potassium has a mass number of 39, whereas sodium has a mass number of 23. So potassium will have a higher density. Yeah, it wouldn't have a lower density than sodium. Okay, does that answer your question? All right. Okay, then let's look at part C. So part C, construct a chemical equation to represent the reaction between cesium and H2O. So that is your group 1 metal plus water reaction, right? So cesium is Cs plus H2O. Group 1 metal plus water, you'll get your alkali and hydrogen. And your alkali is a metal hydroxide, so you'll get CSOH plus hydrogen. Okay, how did I get CSOH? The charge of OH is minus, and the charge of CS is plus, because it's group 1. So the charges will automatically cancel each other out, since both are charge of 1. Okay, 1 plus and 1 minus. So the formula is just CSOH. Then I just have to balance the equation. Yeah, and that should be balanced. Okay, then if you want to add state symbols also can. This will be solid, liquid, this will be aqueous, and this is a gas. Okay, describe how cesium reacts with water. So down the group, the elements get more and more reactive, right? So of course it will react with water very violently and very explosively. Okay. So cesium reacts with water very violently and explosively. Okay, this one I just describe how it reacts with water. If you want to talk about the products being formed, right, which is something extra, it also can. But it is better to be specific, like saying cesium hydroxide and hydrogen is formed. Okay, instead of just saying alkali and hydrogen is formed. Yeah. But this is enough already, because we're just describing how it reacts. We don't have to state the product's form. Okay, then how do you test for the gas release in the reaction? The gas released in the reaction is this, hydrogen. Okay, so the test for hydrogen is very simple. If you place a lighted splint where hydrogen is being formed, there will be a pop sound. Okay, you will hear a pop sound. So you just use a lighter splint. And a pop sound will be extinguished. When your hydrogen gas is present. Okay, if you guys have no questions and you're done copying, just give me a thumbs up so I know I can move on. Okay, looks like most of you are done. I'll be moving on now to your group 17 elements. Okay, so group 17 elements, they are non-metals. And the name that they are called is halogens. Okay, so your group 17 elements are called halogens, which is just a special name. So your elements are fluorine, chlorine, bromine, iodine, and astatine. Okay, fluorine, chlorine, bromine, iodine, astatine. Okay, there are only 5 group 17 elements. And they exist as diatomic molecules. So what is a diatomic molecule? It's basically a molecule that consists of two atoms. Okay, so that's what diatomic means. It is a molecule consisting of two atoms. So your fluorine, your chlorine, your bromine, they will always exist as two atoms. So F2Cl2Br2, there's always a 2 here because they exist as diatomic molecules. Okay, so when you're writing your equation, right, you have what? A plus B give you C plus fluorine. Make sure your fluorine have a 2 here. Okay, so it shouldn't be just F. It should be F2 when you're writing your equations. All right. So let's look at the similar physical properties and the similar chemical properties. So your group 17 elements, right? They are non-metals. So they will have similar physical properties as non-metals as well. And what are some of those properties? Poor conductor of electricity and heat. Okay, your non-metals, they don't have any free electrons or free ions to conduct electricity. So they are poor conductors. Okay, then another one is low melting and boiling points. Okay, a lot of non-metals, they have low melting and boiling points. And specifically for this one, because they have weak intermolecular forces, they are simple covalent molecules. So they have low melting and boiling points. Okay, then the two new ones that you have to learn today is, one is they are brittle in solid state. Okay, brittle means break easily. So whenever a force is applied, it can break already in solid state. And the second one is they are colored molecules. So actually later we'll learn the colors of these molecules, and I have a memory shortcut for that as well. Yeah, to remember the colors. Okay, so those are the physical properties. Okay, now moving on to the chemical properties. Just like other non-metals, they can form ionic compounds with metals. Okay, your non-metal with metal combined together will form an ionic compound. And also, they can form a covalent compounds with non-metals. Okay, non-metal and non-metal bond together will form a covalent compound. So what is special about them is they are group 17. So they have 7 valence electrons. Okay, that is one of their similar chemical properties. And they will gain 1 electron to form your negative ion of -1. Okay, or negative charge of -1. Because your stable electronic configuration, you need 8 electrons. So they just have to gain 1. So that they can form a stable ion. Okay, so those are your similar physical and chemical properties. Now let's look at the trends down the group. Yeah, so this is the more important part, the trend down the group. So down the group in group 17, what are your trends? I have a memory shortcut for this, which is mom cooks rice. Okay, so very simple. Mom cooks rice. Focus on the first letters, M, C, and R. Okay, M, C, and R. And just like just now, right? Everything at the front was a plus except for the last one. So we're going to do the same thing for this. M will be a plus, C will be a plus, R will be a minus. Okay, so everything plus except for the last one, which is a minus. And that is your memory shortcut. So M is melting and boiling point. Okay, so for group 17, right, down the group, the melting and boiling point actually increases. Okay, which is opposite of group 1 elements actually. So your melting and boiling point increase down the group, meaning that chlorine will have the lowest melting point and boiling point. S13 will have the highest melting point and boiling point. Okay, pretty simple. Lowest and highest. C is color intensity. Okay, color intensity increases. What does that mean? Means it gets darker. Okay, So fluorine will be the lightest color, and then astatine will be the darkest color. Okay, the color intensity of the molecules, they actually increase, means it gets darker. So basically fluorine is the lightest, and then astatine is the darkest. Okay, that's what I mean by color intensity. It gets darker. R is reactivity again. Reactivity minus, right? So it decreases. Again, opposite of group 1 elements. Reactivity decreases. So fluorine is your most reactive halogen. Okay. Astatine is your least reactive halogen. Okay. But there's actually one more trend. And why is it not written here? Because it can actually be inferred from one of these. Okay. The last trend is that I'm going to highlight the physical state changes from gas to solid, which means down the group, fluorine is a gas, then somewhere in the middle is liquid, and then the last one, astatine, is a solid at room temperature. Okay, this is at room temperature, 25 degrees Celsius. So how do we infer this? It's based on the melting and boiling points. The melting and boiling point increases, right? Melting and boiling point increases down the group. So since fluorine will have the lowest melting and boiling point, it exists as a gas at room temperature. Then bromine, it exists as a liquid. And then astatine, right, it has the highest melting point and boiling point. So it exists as a solid in room temperature. Okay, so that's how I derive my last trend, which is that the physical state changes from gas to solid down the group. Yeah, and those are your 4 trends. Okay, now that we're done with the trends, let's move on to the colors. Okay, so as we know, right, as we just learned, the color intensity increases down the group. So it goes from very light color to very dark color. So what are the exact colors? Let's look at the color and the physical state at room temperature first. Okay. So at room temperature, fluorine is a pale yellow gas. Pale yellow gas. Okay. Then chlorine is a green gas. Let's see if I got a green highlighter. Yes, I have. Okay, chlorine is a green gas. Bromine is a reddish brown gas. Why have reddish brown? Okay, just put this color. Reddish brown gas. As iodine is purplish black. Okay, and it's a solid at room temperature. So now you see how down the group, right? It goes from like a gas, then slowly becomes a liquid, then suddenly becomes a solid. That is the trend down the group. And then finally, astatine is a black solid. Okay, so we went from pale yellow gas, which is a very light color, all the way to black, which is the darkest color. Okay, then what is the color of them in gaseous state? Okay, where did the yellow go? Is it this color? Yeah. Okay, so color in gaseous state. I remember this using a very, I don't know how I came out with this memory shortcut. Your grandma buys peanut butter. Okay, so focus on the first letters. Okay, the first letter Y. Y is yellow. G is green. B is brown. T is purple. And B is black. Okay, so you have fluorine, chlorine, bromine, iodine, and astatine. Okay, so in gaseous state, in gas form, your fluorine is a pale yellow gas. Okay, chlorine is a green gas, bromine is a brown gas, iodine is a purple gas, and astatine is a black gas. Okay, that's how I remember the colors of your group 17 elements in gaseous state. And you can actually, it's actually quite similar to the colors. It's actually quite similar to the colors in room temperature as well, right? Because in room temperature for your fluorine and chlorine, they are both gas already. So yellow and green. And then bromine, reddish brown. Then gaseous state is brown. So it's quite similar. Iodine, purplish black. And then gaseous state is purple. Astatine, black. Gaseous state, black. So what I recommend you guys to do, right? You just memorize this. You just remember this memory shortcut. And then remember the colors in gaseous state. And then it will be quite similar to the room temperature already. You just have to remember bromine and iodine. Okay, bromine is reddish brown and iodine is purplish black. Yeah. That's it. Okay, those are the colors. Okay, moving on. This one is displacement reaction. Displacement reactions of halogen. So what is displacement reaction? It's basically you have a more reactive halogen, right? It can displace the less reactive halide ion. Okay, halide ion is just the ion of a halogen. For example, if the halogen is fluorine, the ion will be fluoride ion. Halogen is chlorine, the ion will be chloride ion. Okay, that is just what halide ion means. So the more reactive halogen can displace the less reactive halide ion from its solution. This is called displacement reaction. Okay. So let me give you an analogy. In a small office, right, there's this manager named Tom. Okay. The guy is named Tom, and he's the manager. And even though he had the title of a manager for many years, he struggled with decision making, and then he often missed his own deadlines, and he didn't have the skills to lead effectively. Then on the other hand, you have this guy named Jerry, who is just a regular employee who joined 2 months ago. Okay, just a regular employee. But the thing about Jerry, right, he was far more competent. Okay, he's more competent because he could solve problems quickly, he could communicate well, and he basically got the respect of the whole team. So what did the CEO do? The CEO replaced Tom with Jerry. Okay, so Jerry became the new manager, and Tom became a regular employee. What's the moral of the story? The more competent person, which is Jerry, can replace the less competent person, which is Tom, from whatever managerial or executive position. Okay, the more competent person will replace the less competent person. So this is similar to displacement reactions, because the more reactive halogen can displace the less reactive halide ion from the solution. Okay, so now let's look at a chemical example, which is chlorine and sodium fluoride. Okay, no, let's start with the second one, chlorine and sodium bromide. Okay, let's look at this one. So in this reaction, you have two halogens, right? One is your chlorine, and one is your bromide ion. Okay, which one is more reactive? If we scroll up, right? Remember the reactivity decreases down the group. So your chlorine is here, bromine is here. The one above will be more reactive, okay? So since chlorine is above bromine in the group, chlorine is more reactive than bromine. Since it's more reactive, it is able to displace the bromide ion from sodium bromide. Okay, so chlorine react with sodium bromide, it will displace it. So once it displaces, they basically swap position. Now you have sodium chloride and bromine. Okay, so it's a very simple reaction. You have these two, right? They basically just swap position. No? So this one becomes sodium chloride. This one becomes bromine. Okay. So chlorine is more reactive than bromine, so it can displace the bromide ions from the solution, sodium bromide. Okay. Then what are the observations? Because chemistry questions, they really like to ask what are the observations. You can say that the solution changes from colorless to brown. So the colorless solution comes from the sodium bromide, which is colorless, and then the brown color comes from bromine. Okay, remember bromine is a reddish brown liquid at room temperature. So that's where the brown color comes from. So solution changes from colorless to brown. That's your observations. Okay, then now let's look at the first example, which is chlorine and sodium fluoride. Okay, so you have chlorine here and fluorine here. Fluorine is actually more reactive. Fluorine is actually more reactive than chlorine. So since chlorine is less reactive, it is unable to displace your fluoride ions. Okay, just like how if Jerry was less competent, right, he wouldn't be able to replace the manager, correct? So since chlorine is less reactive, it is not able to displace fluoride ions from sodium fluoride. So no reaction will happen. Okay, as simple as that, no reaction will happen. Okay, that is your displacement reactions of halogens. So now I want you guys to try two questions. Question 2 and 3. Okay. So question 2 is an MCQ. Question 3 is a short structured question. I'll give you all 6 minutes. Okay, so 8:56 we'll discuss. 8:56 I'll go through. And again, you can send your answers in the chat so I can give you remarks. Okay, now I'll go through the questions. So let's look at question 2. Part of the periodic table is shown. Okay, so you have W, X, Y, and Z. Which of the elements, W, X, Y, and Z, will react together least violently? Okay, if I want the least violent reaction, right, I will want the least reactive metals. Sorry, why did I say metals? Least reactive elements to react with each other. Okay, if I want the least violent reaction. So let's look at the trends. Okay, for those who just send their answers, I'll give feedback later. So now I'll go through the questions first. So the trend down, this is group 1, right? And this is group 1, this is group 17. Group 1, your trend is DARM plus minus. Okay, so we focus on reactivity. Reactivity increases down the group. Okay, so if reactivity increases down the group, which one is your least reactive metal? W. Okay, W will be less reactive than Y. And then for group 17, you have X and Z, right? The trend is mum cooks rice. So reactivity decreases down the group. Reactivity decreases. So what is the least reactive? Z. Okay, so your answer is B, W and Z. Because both of them are your least reactive, so they'll react together the least violently. Okay, now let's look at question 3. In an experiment, chlorine gas is passed through a tube as shown below. So the tube shows chlorine gas being passed through potassium bromide and potassium iodide. Okay, then there's some gentle heating here to help a reaction to happen. So after a short while, colored vapors are observed at P and Q. So P is over here, Q is over here. State the colors of the vapors observed at P and Q. So what happens when chlorine is passed through potassium bromide? This is obviously testing you on displacement. So we have to look at the reactivity. you have fluorine, chlorine, bromine, iodine, acetate. Okay, and then down the group, the reactivity decreases. So chlorine is more reactive than bromine, so it is able to displace your bromide ions. Okay, so if it displaces your bromide ions, both of them will swap side. So now what do you form? Potassium chloride and bromine gas. Okay, why is it a gas? Because there is heating. So heating caused the temperature to increase and thus making it a gas. So what's the color of bromine gas? It is reddish brown, right? If you look at, okay, it is brown, brown or reddish brown, they are both accepted. If you look at this table actually. So can either say brown or reddish brown. Okay, what about Q? Q is after it reacts with potassium iodide. So now I replace bromide with, now I replace bromide with iodide, right? So you have, I'm going to write it here, chlorine plus potassium iodide. Okay, so you have chlorine and iodide. Chlorine is here, iodine is here. So chlorine is more reactive than iodine. So it can also displace your iodide ions to form potassium chloride plus iodine gas. Okay, why is it a gas again? Because there's heating involved. So what is the color of iodine gas? It is purple. Okay, iodine gas is purple. Okay, part B. State and explain the trend in the reactivity of elements in group 17. So there's two parts to this. One is you have to state the trend for reactivity. The other one, you have to explain the trend. So reactivity in group 17 will be it decreases. Okay, reactivity decreases down your group 17 elements. That's my statement. Okay, once I write that, I get 1 mark. Then how do I explain? First, we need to understand what does it mean for group 17 elements to react. They react by gaining 1 electron to achieve the stable electronic configuration, to achieve the negative ion of -1, right? So your group 17 elements react by gaining 1 electron to achieve a stable electronic configuration. Okay, which is basically a full valence shell. Okay, so why does reactivity decrease? As you go down the group, right, the atomic radius of the elements will increase. Why? Because the number of electron shells increase. Let's look at fluorine. Fluorine will have 2 electron shells. Chlorine will have 3 electron shells. And there will be more and more electron shells as you go down the group. So the atomic radius will increase. Okay, so down the group, okay, The atomic radius of the elements will increase as the number of electron shells increases. So this is fluorine, right? And this is chlorine. Sorry, fluorine should have 7 Okay. So inside your elements, right, you have a nucleus, and your nucleus is actually positively charged because your nucleus contains both protons and neutrons. Okay, protons are positively charged, neutrons are neutral. So your nucleus itself is positively charged. And then your electrons is negatively charged. So there is a force of attraction between those two. And as the atomic size get bigger and bigger, that force of attractions get weaker and weaker. Okay, so your nucleus here, with the force of attraction with an outside electron, gets weaker and weaker. So it's harder to gain an electron, okay, because of the weaker attractive forces. So this causes weaker forces of attraction between the positively charged nucleus and the valence electrons. Okay, therefore your group 17 elements reactivity decreases. Therefore, they will gain an electron less readily down the group. Okay, and if it gains an electron less readily down the group, it means it is less reactive. Okay, it gets less reactive down the group. Okay, for part A, R is a solid iodine. Why is it black and not purple? So the purple, right, what it's saying is it is like purplish black. So it can be black purple. Sorry, so it can be black or purple. And this in this case, the question just says black solid. So the black solid is iodine. Okay, then previous question. For question 3A for P, why is it just brown and not brown and purple? Because it's beside the potassium iodide, which will release a purple gas. So the question is just wanting to test you on the color of what is being formed. Okay, so bromine is being formed here, but the bromine does not react with the. Oh, okay, I know why already. Okay, that's a good question. Bromine actually reacts with the potassium iodide. Okay, so not just chlorine, right? Your bromine reacts with your potassium iodide. Okay, let me just write in chemical form. Bromine reacts with potassium iodide to form potassium bromide and iodine. Okay, so there will be no more bromine gas at the end of this reaction. That's why at Q is only the iodine gas form. Okay, yeah, that's why there's no brown gas. It is just purple. Because all the bromine is used up to react with potassium iodide. Yeah, okay. Okay, once you guys are done copying, just give me a thumbs up and I'll move on to the last part. Okay, so the last part I combine both, right? I combine both group 18 elements and transition metals because each of them the content is quite little. Okay, so for groups 18 elements, they are called your noble gases. Okay, and these are the group 18 elements. You have helium, neon, argon, krypton, xenon, and radon. So group 18 elements, they are unreactive. Okay, why are they unreactive? Because they have the maximum number of electron shells in their valence shell. Okay, meaning that they have a stable electronic configuration. So why would they want to react when it's already stable? That's why they are unreactive. Okay, so they exist as monoatomic elements, and monoatomic elements are elements that exist as a single atom. Okay, so you'll see helium as just helium, neon is just neon. There won't be a two here. Okay, because it is not diatomic, it is monoatomic. Okay, and then just a few applications that you will need to learn is your helium, it is used in balloons. Okay, your neon and argon, they are used in light bulbs and in the manufacture of steel. Okay, for argon. Yeah, and that is basically it for group 18 elements. You just have to know they are called noble gases and they are unreactive and monoatomic. Why are they unreactive? Because they have maximum number of electrons in their valence shell. Okay. Okay, I'm not done with the last part. Could scroll up a bit. Is it here? Okay. For those who cannot copy finish, right, don't worry because this I'll send my inkings in the Telegram channel as well. Yeah, so don't worry if you cannot copy finish. And also this whole meeting is recorded. So you can rewatch the whole crash course. Yeah. So I'll just stay here for a few more seconds, then I'll move on to transition elements. Okay, so that is it for group 18 elements. For transition metals, they are metals that occupy the central block of the periodic table. So basically from group 3 all the way to group 12, these are your transition metals. Okay, from group 3 all the way to group 12. So this whole thing, they are your transition metals. Okay. So they are metals also, right? So they'll have typical metallic properties such as high melting and boiling point, high density, and can conduct electricity and heat, and ductile and malleable. But how do we differentiate them from group 1 and group 2 metals? I use this memory shortcut, very cute cat. Okay, VCC. So V is variable oxidation state. Okay, so for those Sec 4s, right, who have already learned redox oxidation states, you'll know what this means. Okay, it means that they can have different oxidation states. Yeah. And then form colored compounds. Colored compounds. So what are some examples of the colored compounds that they form? Example, you have iron 3 hydroxide. This is reddish brown. Okay, so iron is a transition metal. Then the compound it formed, which is iron 3 oxide, iron 3 hydroxide, is a reddish brown compound. CuSO4 is blue, and copper is your transition metal. Okay, so you get the idea. It forms colored compounds. And the last one is they are good at being catalysts. Okay, catalysts are basically substances that speed up a reaction. So since they have variable oxidation states, we like to use them as catalysts so that they can, speed up the reaction. But yeah, you don't have to understand in detail for this. You just need to understand that they are often used as catalysts. Okay. So what are some examples of catalysts? You have iron in the Haber process. Okay, this is the process of making ammonia. You have manganese 6 oxide in the manufacture of margarine, and you have vanadium 5 oxide in the manufacture of sulfuric acid. Okay. So the main point is transition metals, they have variable oxidation states, form colored compounds, and can be used as catalysts. Okay, and they are also less reactive than other metals. Can a compound of a transition metal act as a catalyst? Yeah, can. So like one of the example here is manganese 6 oxide, right? That is a compound with a transition metal, and it's also a catalyst. Then here we got vanadium 5 oxide. Yeah, so compounds of transition metals, they also act as catalysts. Okay. Yeah. So your transition metals, they are often used as catalysts. Okay. So just 2 MCQs for you guys to try. I'll give you a quick 3 minutes. Yeah. All right, that was a quick 3 minutes. So let me go through the question now. Arc welding is a process which uses electricity to make high temperatures, okay, to melt 2 pieces of metal so that they can be joined. Argon is blown onto the surface where the molten metals are joining. Why is argon used? Okay, so option A, it reacts with oxygen, releasing heat which helps the melted metals to melt. So the thing that it reacts, right, is already wrong because your argon is a noble gas, and noble gases, they are unreactive. So cannot react with oxygen. B, it gives us a lot of light to help the welder see what they're doing. Okay, so argon can be used as a light bulb, so it can be used to give off a lot of light. But what is the point here, right? We just want to use electricity to make high temperatures to melt 2 pieces of metal. Okay, so you don't really need to give off a lot of light to see what is happening. So B is out. It is a good electrical conductor. Immediately wrong. Okay, they are not good electrical conductors. And finally, it's an inert gas which prevents the metals from oxidizing. So it's unreactive, right? Inert gas is the same as unreactive gas. That is true. And preventing the metals from oxidizing is good as well. Because your goal is to melt the 2 pieces of metal. You don't want them to oxidize to become another compound. Or you don't want them to be destroyed. So D is your answer. Okay, so it's unreactive, so it prevents the metals from oxidizing. And it's placed at the surface of the metals as well. Okay, question 5. Vanadium has various oxidation states and forms colored compounds. Immediately, I know they are testing me on transition metals. Okay, because those are the 2 properties of transition metals that differ them from other metals. Okay, so you have some information. Equals VO2 plus is blue, VO2 plus yellow, V3 plus is blue-green, V2 plus is violet. Okay. So which statement is correct? If a vanadium compound solution changes from color violet to blue-green, reduction has taken place. Okay, so I know there are some sec 3s here. So if you haven't learned reduction or oxidation yet, one of the definition of reduction is a decrease in oxidation state. Okay, so if we look at violet to blue-green, right? Violet is V2 plus, blue-green is V3 plus. Okay, the oxidation state is the same as the charge. So oxidation state of this is +2, and oxidation state of this is +3. So there is an increase from +2 to +3. So definitely reduction has not taken place. So A is wrong. Okay, vanadium has high density. That is actually a property of transition metals as well, because they also have properties of normal metals. So B is actually your answer. Vanadium compounds are unlikely to be catalysts. It's actually the opposite, right? They are likely to be catalysts because they are transition elements and transition elements in a compound. And finally, low melting point is wrong because they have high melting and boiling points. Okay. So answer is B. Then now I would like everyone to go to kahoot.it. Okay, we'll start the Kahoot shortly. Okay, good. Most of you got it correct. So reactivity increases down group 1. Okay, good job, Zichao. Okay, which of the following is correct property of alkali metals? They are soft. Okay, most of you got it correct as well. Okay, now Irfan is in the lead. Okay, what is produced when group 1 metal reacts with water? You will have an alkali and hydrogen gas. Okay, so alkali is also your metal hydroxide. Okay, good job. Yes, as you go down group 1, just remember the memory shortcut down plus 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 minus. So the melting and boiling point will decrease. Okay. Question 5. Good job, everyone got it correct. Becomes darker. So down group 17, the physical state changes from gas to solid, and bromine is right at the middle. So it's actually a liquid at room temperature. Okay, Emmeline and Clarine is catching up. All right, so when chlorine is added to sodium bromide, it will displace bromide ions because chlorine is more reactive than bromine. So chlorine displacing the bromide ions, they swap place, right? So what are the products formed? Sodium chloride and bromine gas. Okay, so your bromine gas is brown and your original sodium bromide is colorless. So the solution changes from colorless to brown. Okay, good job to the 3 of you who got it correct. Okay, now Emmeline is in the lead. Why are noble gases unreactive? Because they have full valence shell. Okay, they already have a stable electronic configuration. All right. Second last question. So transition metals, they have high melting points. Okay, they definitely don't have low density, they have high density, and they are not very reactive, and they have good electrical conductivity. All right, final question. True or false? Faster look at the periodic table and you can answer. Should be false, huh? Why? Because aluminium is in group 13. Okay, aluminium is over here. So it doesn't fall in the range of your transition metals. Transition metals from group 3 to 12. Aluminium is in group 13. Okay, so that's why aluminium is not a transition metal. Okay, let's see the podium. Third place we have Clarine, good job. Second place, Ricky, nice. And first place we have Emmeline. Okay, congrats to everyone. Now let me go back to the PDF. Okay, so now I would like all of you, right, to think of one thing that you improved the most today. Okay, what was one concept or one part that you benefited or you improved the most today from this crash course? Okay, once you have thought of it, type it out in the in-call messages. Okay, everyone, I want everyone to share at least one thing. Okay, type it out in the chat. What is one thing you have improved or learned today? Learning how to form the formula for group 1 elements and the shortcuts for each group's characteristics. Okay, nice. I improved more on my concepts of noble gases. Okay, nice. Noble gases. Knowledge on valence shells. Ricky said, I learned group 1 metal plus water give H2. Nice. Characteristic shortcut. Improve understanding of transitional metals. Okay, nice, nice. Okay, very good. So, looks like most of you at least learn one thing today, okay? Because if you all learn nothing, this whole crash course will be a waste, right? But since you all have benefited, that's nice to hear. Okay, so now I will share my class details, okay? If you are thinking of joining our regular classes, right, if you are Sec 4, don't wait any longer, because first reason, right, most students, they have this silly hope, okay, that chemistry is going to get better, you know, you're going to figure it out when it's closer to O levels. But no, it won't just magically happen. Because of personal experience, you know, when I was Sec 4, right, throughout the year, my physics grades just got worse and worse. And then when I joined tuition, I realized that I had such a bad content foundation. So it really helped me when I had the support I wanted. Okay. Yeah. And next, right, here's what you get if you join. So you have your weekly lessons. You have the one thing we provide, right, is 24/7 WhatsApp help. Okay, so whenever you have questions, you can just ask me on WhatsApp. Yeah, then I'll reply within a few minutes. Okay. Definitely before the next day, I'll reply already. And then you have your notes and resources, your crash course clips, past lesson recordings. Okay, these are all free. Okay, so I'm only charging you on the weekly lessons. Yeah, which is $80 a week. Okay, so we're opening a few more spots in February. If you want to join, we have these two available classes. Okay, Sundays 3 to 5 and Mondays 7 to 9 p.m. So if you're interested, you just send me a WhatsApp message, or you can go to tinyurl.com/signuplch. Okay, if not, right, can you guys scan this QR code and fill this feedback form? I really appreciate it, so that next time we can provide even better crash courses for you guys. Okay, then if you can't scan the QR code, you can go to the link tinyurl.com/lch feedback. All right, thank you for filling up the feedback form. So for those of you who finished filling up, that will be the end of today's crash course. So thank you so much for coming today. And yeah, hope it all benefited you guys. Okay, so I'll stop the recording. Thank you. No problem. Okay, and I'll